I think we can get started. Welcome to one of your last session, I guess. It's here at Cisco Live. I hope it will be worth your time, and I'll get you interested in what definitely interests us these days. Let me just introduce myself. I'm Giovanna Carofiglio. I'm a distinguished engineer with Cisco for 10 plus years and another 10, 15 in networking. And today I'm part of Outshift. So Outshift is Cisco incubation engine. It's an organization that works on new technologies and experiments with them and applies them to products across the Cisco portfolio. And these days, our organization is focusing on agentic AI. I'll say a few words later, of course, and quantum networking and computing. So if you are interested, of course, you can browse the session catalog, and you'll discover other sessions from our team. But today, I want you to go through the work we have done in the past year with our teams on application of agentic AI and a few other key technologies, network digital twin, NetDevOps practices, in order to improve, simplify, accelerate, make less costly the network change validation process. Just a disclaimer, please do interrupt me at any time if you have questions. I prefer like that. So if you have questions, if you don't understand, if there is something missing, please raise your hand, and we'll take them as we progress. Of course, you can join the WebEx space. I think you're already by now familiar with this. If you have questions, even after the session, please do reach out. It will be a pleasure to answer to them. So very quickly, what are we going to cover today? So I'm going to start with the problem. Pretty sure you're very familiar with that, but just to have a baseline. And then I'm going to discuss the approach that we have experimented with and the key components, which again revolve around network digital twins, agentic AI, and in integration in the NetDevOps workflows. And after that, I'm going to walk you through one scenario end-to-end so that you can really see the integrated solution in action. And I'll spend some time towards the end of this session to explain how we build these agents, what's a bit the behind the scenes for the solution, especially for the agentic components. And that said, I'm going to also introduce you to an initiative that our organization, Outshift, had launched recently, which is called Agency, which simplifies the development of agentic application by introducing tooling and protocols and solution for observing, evaluating agents. And that has been really key for the development of the solution that we apply here to the network change validation project. Quick overview of the problem that we have looked at. So of course, there is a lot of interest in looking at the pre-deployment and post-deployment change validation as a unified solution. With our teams here, we have looked into the steps for pre-deployment network change validation, so everything related to defining the change candidate, assessing the potential impact, defining a test plan, test cases, and then leveraging the proper tools for testing in order to reduce the risk and being able to also predict the potential unintended consequences related to the change. And that, of course, resulting that into the approval of CAB. So these are pretty conventional steps. I'm going to show you a few numbers. But first of all, I want to ask you a question. Anyone here has faced issues due to network changes in production? Pretty many. That's what I thought. So yeah, I'm not telling you anything new here. Of course, this is an important problem, and we believe this is still there because the process is today heavily manual. Of course, the automation transformation is there, but it's not fully there when it comes to network change validation. And it's still a lengthy, error-prone process, not just because it's a manual process, but because it involves multiple testing tools. And we're going to touch upon this, what are the categories and how we select the good mix of testing tools so that really can cover in a scalable, effective way all the aspects related to the potential risk of the change deployment. And yeah, this is, of course, the root cause for most of the network outages and has significant impact in terms of business. Now, I want to have your feedback. So this is our baseline process. So we have talked to many customers, and we know that there are multiple variants. But we have tried to sketch, as a starting point, a change validation process, again, before the change is deployed in production, in order to capture the different steps. If you have comments, or please let me know. I'm going to walk you through this, even though I'm pretty sure you're very familiar. So the first step is clearly the declaration of a change intent in text. It usually comes with the creation of a change request ticket in an ITSM tool. We have integrated with ServiceNow. There are many others. And that change intent triggers a first phase of change intent analysis. So usually what we want to know before the approval to the change implementation is what is the potential impact. And that usually is used to associate a severity to the change and also to have different versions of this process here. The second step is trying to define what are the aspects that should be tested. And with all this information, so essentially the impact assessment and the test plan, a peer review happens and the change implementation is approved so that really we can move into the phase of developing the change candidate, testing the change candidate, which is, again, a big chunk of the work we have done here with the agents. And finally, reporting the results. It can be following the same life cycle of the ITSM tickets so that a change advisory board can approve the deployment in production. And then there could be some additional tests, as we said, post-deployment. And I think all the ingredients of the solution that we're going to see later in the session could be also potentially applied to post-deployment testing. Any comment here? Does it look like strange? Taking this as a no. So, OK, why do we want to improve things? So we have interviewed multiple customers, and we have got feedback like this one. So people would like to have single tool, single pane of glass, not have to go ingest data from multiple data sources, checking multiple network source of truth, applying different testing tools, going through all this very human-based process, but rather have a tool that does it all. So can we have something, this is what they were expressing to us, some sort of AI tool that can model the different steps of the process, automate that, and also reason through each step. That, of course, calls for agentic AI. So these days, as you might be aware, we are moving from the use of single models to agents, which actually don't just have the capability to call a Gen AI model, but they also have a memory. They also have the capability to reason and repeat operation and assess the results and collaborate. This is why we call it agentic AI, because it's not necessarily one agent, it's not necessarily one model, it's multiple agents, each one with its own capabilities. You should think as a team with, you have multiple subject matter experts, each one skilled with different skills, and that they can collaborate. Is this still very futuristic. That's what we thought. I can say that as a network engineer, we approach this with quite some skepticism. But actually, yeah, you're going to judge yourself. This is really coming. The results are there. And even some very old school network engineers had to realize that. So agentic AI is one component. I'm going to come to that. But we have realized pretty soon in this process that in terms of networking data to ingest in real time and to structure and to reason through, what was really important for these agents to properly execute their tasks is a unified, realistic replica of the network in production. And so there, we have tried to analyze. There has been a lot of hypes along the years about creating network digital twins. This is actually revived today, even because of the use of generative AI that can help by ingesting a lot of volumes of unstructured data to define these network digital twins. So there, I'm going to explain, it's a key component of our solution because it really provides the agents unified data reference, always in sync with the production network that they can use to reason through, to apply, to test, to change, and come to a result that doesn't affect directly the network in production. And finally, NetDevOps operation. This is kind of a no-brainer. But what we believe is important, especially because many of you are undergoing this automation transformation, is that it's important that all these operations are embedded in the workflows that already exist. So we don't want these agents to live somewhere else. We don't want you to have too many tools to interface with. Where the change implementation is developed, this is where these agents will live. And the network digital twin that they use as a tool will also be integrated. And as you can see here, these three pillars, they come with different benefits. And the integration of the three is really what we have seen brings more differentiation. But this is still a bit too abstract. So let me explain what is the approach that we have followed. And we are going to look at the different pieces one by one. So we have the network in production. We are ingesting data from this network. Could be directly from a controller. We have internally worked on NSO and CNC. We have worked on Catalyst controller integration. The approach is not specific to a particular source of data. It should be general enough so that you can ingest very easily your data sources. The schema that we have used is an extension of OpenConfig. Again, there are pros and cons. It's a starting point. There could be other version. I don't think this is very much important. But what's important is that all this telemetry flows and is structured in what we call a network digital map. It's the highest level of our network digital twin. It's a way to represent the large volume, especially if we are talking about large networks of data related to physical topology, layer 2, VPNs, routing protocols, traffic metrics. It could also be traffic flows, performances, SLAs, and so on, going up into the stack. What's important, and this is something that has been made possible in the past 3-4 years by the advent of knowledge graphs. Don't know if you're familiar with that. They are essentially ways to structure the information so that you can have a very rich, sometimes Turing-complete query language to search patterns or to compute things on top of this graph-based representation. So this is something that is very much used also in cybersecurity for threat detection. This is something we have been working on in the past. You can find it in many domains. It's today pretty easy to define. We have been using ArangoDB for those who are familiar. There are other solutions such as Neo4j. Even the storage of data is optimized so that you can really have a very efficient and effective way to search the information throughout the graph. So this is the highest level of the NDT. And then we have structured the tools of the NDT, so the testing tools, in layers. I'm going to explain why and why we have defined it like that. Also integrating open source solution. You see Batfish, for instance. I'm going to say a few words on that. Microsoft DeFi. You can have tools that you're already familiar and maybe you're already using for these reasons. Network digital twin, a window into the networking production, always in sync. You can extract snapshot from this NDT over time and then apply your change and do your testing on top of it. The agents, let me introduce the agents. So we have built our application by structuring the different steps and assigning tasks to these 5 agents. You're going to see them in action. It's going to be more clear. But essentially, we have one agent that is also the interface with the user. This is what we call the assistant or the co-pilot. And he can answer questions about anything related to the networking production by accessing the network digital twin. We have agents such as agent 2 and 3 that are specialized in tasks for our network change validation workflow. Impact assessment is one, test planner. You're going to see that in action. And finally, we have an important agent, the test executor. So here we are not yet analyzing the intent, but we're really already in the testing phase of the change implementation. And data agent essentially translates a test plan into test cases that are really coded and allowed to execute by calling the tools of the NDT. And again, the abstraction of the NDT makes it very easy because you don't have to go and configure your simulations or define what you want to verify on top of your network digital twin. Please.
So I noticed there's a layer of emulation, right? So are you guys taking the production config and applying that within the emulation layer and then using your telemetry data and your agents to apply config within that environment and then produce that as an output for the intent?
Yes, but not all the time. So these layers are, and I think it's a good segue for the next slides, are different approaches. So today, if you want to test your change candidate, you are most likely picking one of those. So if you're familiar with emulations, yeah, you can use, we have a few examples, CML, what we may use internally, even GNS3. But these emulation tools, which are good because they provide a very realistic representation of the change, they don't scale much. We have tried to use them even as a ground truth for the other type of testing. It's been a painful exercise. They can be good, though, to test specific, very small portion of the network related to the blast radius. So they could be an additional step. As actually, in place of emulation, I would say a physical lab can also be an equivalent good alternative. But we are not relying only on emulation. Our first idea was to combine. We have been working on this for years, but actually, I think the key here is that you don't have to choose, because you can combine these multiple tools and let the agents decide based on the change, based on the network status, based on what the user wants to verify, go through tests starting from the formal verification that you can have with the model-based representation. I'm gonna mention what we are using, but essentially all the formal verification tools use a mathematical model to represent the forwarding function across the network. It scales, but this is mostly used for static analysis. So if you want to predict what is the impact on a specific traffic flow on a specific SLA, this is not the right tool for that. Simulation, this is a good intermediate steps when we look at the trade-off between realism and scalability. It's mostly used for performance assessment, for traffic engineering. It really allows to do a dynamic testing, but it comes with its own limitations. So I'm going to go quickly because I'm pretty sure you are familiar, but I think it's important to understand the pros and cons of all these tools and try to define our own. So model-based verification, we have looked at solutions such as Batfish in open source or Forward Networks as a product, and they rely on a technology called HSA, header space analysis, which essentially, in short, is a mathematical model that represents your network by looking at packet header, and each bit represents a dimension. So in this multi-dimensional space, a change is essentially mapped into a transformation of the header function. And the beauty of it, that is just computation. It's something that you can compute directly on top of your network digital map. It scales pretty well, but it's limited in features. And again, as we said, even though there have been a lot of recent improvements, it still remains related to static analysis. And in terms of protocols, well, working also with customer, we've faced some limitations. So I tell you something, IPv6 or SRv6, MPLS, they were not supported. So if you want to use these tools, there is also work to do there. The good thing of Batfish is that it's an open source project, started with IntentionNet, has been acquired by Amazon, and you can contribute. So this is what we have been doing, working on this. Simulations. We said that, yes, they are used mostly for assessing the performance of traffic in dynamic scenarios. There has been a lot of work there. Personally, I've worked on that for years at the beginning of my career. But there is something which is very recent that I want to point out, is the use of graph neural networks. So we're not talking about Gen AI, we're really talking about traditional machine learning, graph neural network that can be trained on top of the simulated network. There is a project that we have started working on, and we have a collaboration with the university. So it is an open source project called RouteNet that has been going on for 5 years, still very active, where essentially they have ingested data and experimented with networks coming from many ISPs and enterprise customers, and they have trained this GNN. And the beauty is that when you want to reuse it, you don't have to necessarily retrain. So the GNN model is already capable of doing predictions. I think I have a slide here. So what it does is essentially takes as an input the traffic metrics, the characterization of the traffic at flow level, some QoS parameters, and based on that, it provides as an input some performance metrics like delay, loss, jitter per flow. And it works pretty well. They've done a lot of versions of this RouteNet model family. We are using the last one, and is integrated. It's, again, open source. We're trying to leverage tools that are in open source so that people can continue the work. And actually, the scalability of this is the same as the model-based approach. because you are not doing simulations. You are really trying to leverage a model who has learned, who has been trained on simulations to do the prediction. And final emulation, yeah, we touched upon this already a bit. I would say that the main limitation is scalability, not just in terms of size, but even in terms of throughput. And yeah, there is a certain use that can be done on specific, very small side network or portion of the networks, but it's just, I would say, to complement the previous testing approaches. Do we have to choose? No, we don't. So what we are trying to do is to provide these tools in a multi-layer approach to the agents so that the agents can learn by applying a change, given the type of the change, given the status of the network, how to use them. You should essentially think, or at least this is how I think of that, as a cone, that the agents see all the information about the network digital map. They know they have at their own disposal these tools, but they're not going to start from the most scalable model-based one to simulation, and in some cases, if there is need for a further verification, more realistic one, they go into emulation or physical lab. We have packaged all of this, and now, by now, I think you are wondering, okay, where are the agents? So this is the testing part. It's important. We are leveraging the state of the art. We're just integrating them in a way that can be used by agents. We cover most common categorical changes: device topology, path, flow. And now the interesting part comes. Okay, how the agents and why we should apply agents to this process, because in principle you can automate that and you already have a testing pipeline. Well, what we have observed, again, by doing experiments is that, well, first of all, the agents simplify the interaction with the tools. You don't need to understand all the parameterization of these tools. You can interact with the tool by using a natural language interface. That's a no-brainer. Also, by collaborating one with each other, you can automate the process end-to-end. It doesn't mean that you're not controlling it. You may want probably to have human in the loop and multiple steps to verify that things are going as expected, but it's a definitely huge acceleration with respect to what you would do today. And then these agents are particularly well-placed for analyzing large volume of data, doing search by querying directly the graph of the network digital twin, repeat operation and learn from them. So we have seen a huge improvement by introducing React and reasoning patterns into our agents. And they can correct, they can learn from their mistake, and they can correct. So by doing that, they essentially build an expertise, which is the one that today NetOps engineers have on a specific network. Now, what is the agentic workflow? And then we're going to progress, and I want to show you the demo. But essentially, the same workflow we have seen before looks like this now. So we have this change intent. It's expressed in ServiceNow, just an example. The Copilot agent is integrated in ServiceNow. So as soon as a change request is created, it's going to go analyze it, and you can already interact with it to understand, can you summarize me? You're going to see this in the demo. What is the change about? What is the status of the network? What are the potential implications, and so on. Then you can call the two other agents specialized in impact assessment and test planning before we really move to the testing of the change candidate, which happens by having access or be embedded into the development pipeline for the change implementation. And on the change candidate, the test executor agent is going to take the change intent, take the test plan, take also the analysis of the impact assessment, look at the tools that the NDT provides and craft a plan, call the APIs, codes, the tests that reflect that test plan. Once that is done, it's going to look at the results. So it's the same agent that is going to look at the results, see whether more tests are required, point out if there are some tests failed, to what are the reasons for that, and highlighting what should be changed, and then you can iterate. So the idea is that the developer itself of the change implementation will adapt, looking at this recommendation until is satisfied by the outcome. And then all the artifacts produced in terms of document for the impact assessment, test plan, test report, they are attached to the ServiceNow ticket and sent to CAB for approval. A few words on the agents. So we already said we have these few agents. The last one is not doesn't use an LLM. It's rather doing prediction, as we said, leveraging GNN. But the 5 agents above, they do different things. What they have in common is that, and this is because by experimenting on that, we have seen the improvement. They all leverage a React reasoning loop. In most of the cases, we have started with open source, like we have done for tools. We have started with open source models, even though other models work pretty well. We have realized that foundational models are good. Once you have parameterized, you may see difference. But they all have a pretty good understanding of networking or open config data schema. So they are a good starting point. For just one agent that, on which we have spent quite some time, we have seen that fine-tuning of a model was required. This is the NDM query agent. So it's the agent that is the interface to the network digital map, to the graph, and is essentially translating asks from the user or from the other agents into queries. So there, you cannot allow for random answers. So you really have to make sure the model has some coding capabilities. So we have started from this QN 2.5 coder model, and we have fine-tuned it. And so in that sense, you can see this agent as really part of the tool or the agentic interface of the network digital twin. And this is used by all the other agents. I have, I think, later a graph of how the agent collaborate. A few examples of what this agent do, you can have them on the right. So here, for instance, you can ask them any question about change requests or the network status. This is taken from the demo that I'm going to show you later. These agents interact with each other, but they also interact with tools. So in this case, we have the ServiceNow integration. We have the NDM and DT integration, of course, and the collaboration with the test planner, impact assessment, and the query agent. Here, I think this is interesting. So this, again, is the agent that is the interface to the graph. Look at the example there. So you might have the simplest question in the world, what is the IP address of a device? But because the schema for this large network and all this layer of information is quite nested, it requires the agent multiple iteration and reasoning steps in order to get to the answer. This was not intuitive for us, but is essentially due to the complexity of the data schema that is associated to very large networking production. So that's very important. Again, this is one of the aspects which we have worked more upon. These two, you can see them directly. Definition of a test plan is essentially a text description of the test cases. And again, these agents interact with the tool by leveraging the NDM query agent. Test executor. This is interesting because it's the one, again, really taking action on top of the change candidate. you can see that it takes as an input, again, the test plan. The change candidate in terms of code, it was shared by sharing here a pull request in a GitHub repo. It's not a requirement. You can provide access to the code of the change implementation in a different way. And then based on this input, it provides really the execution of the test cases, a report, and it also formats the report in a document that you can attach to the ServiceNow ticket. How it interacts with the NDT, here you see it a bit. So essentially, once he has defined the test cases in terms of code, he calls the NDT, the proper NDT tools. It does a fork of the snapshot in production. So it takes the NDM, the latest snapshot, it forks, it applies the change candidate on top, and then it does the differential what-if analysis and applies the test cases to get to the result. We do this at which level? Well, I told you before, depending on the tools you use, you may go from simple model-based verification, which is going to be at control plane, at data plane level, with, for instance, tools such as Batfish. But you can go beyond and look at flow level characteristics, SLA satisfaction, and this implies the use of the GNN simulation via the solution routeness that which we have integrated. How do they collaborate? Yeah, I'm not expecting you to read. I never, I think, read really well here, but it's a very complete, just to show you how the agents interact with each other and interact also with the tools. So you have, for instance, the ServiceNow, the ITSM tool there. You have the NDM or the NDT tools used by the test executor agent, and you also have the UI, just for another interface with the user. Simple use case, we are considering a firewall policy change due to the addition of a new partner who is going to be given access to a specific CRMAP server, and that implies inbound, outbound, and internal policy change. We just mimic simple subnet mask errors in order to see the results of the tests and the failed tests before correcting that and making sure that all the tests are passed. The video, the workflow, so it really starts from ServiceNow. Don't know how much you can read. And it creates a new ticket. Provides the description of the change intent that you've seen in the slide before. So really high level, what's the goal of the change? Doesn't have to be detailed. The initial phase of analysis will be as good as the information provided in the change intent. And here is our UI. So you can see the new change is uploaded, and then you have this conversational interface with the assistant. And there you can start asking basic questions. Again, can you summarize to me what is the change intent associated to this change request? This is very open. We have tried just to highlight some basic questions that you may want to ask, but in reality, is really you should see it as a window into your production network. So it's able to answer any question related to your network. Then it calls the impact assessment agents. It's done behind the scenes. I will show you later how the agent interact. Here you only see one agent. It's called Heater because Heater is the code name of our solution internally. And now it has provided information about the impact assessment, highlighting what are the affected devices, what you should be looking for in terms of tests. This is going to be attached. I think the next question is, can you attach this to the ITSM ticket? This, again, to keep track about all the outcomes of the steps in the process. It could be automated. In this case, you're just asking the agent to do that. So we haven't accelerated the process. It's just the same latency that we have when we have recorded. This is the latency that you can expect, the responsiveness that you can expect from these agents. So here the agent has copied the information provided by the impact assessment agent into ServiceNow. And you can also move to the next steps of generating a test plan. Again, each of these steps, you can customize it. This is the process that we have used as a baseline. You can see the timeline on the right. So the different steps performed by the solution and by the different agents appeared in a chronological timeline. Accelerate a bit. So this is attached to the ticket. Now we want to move to the phase really of executing tests on the test candidate. So what do we need is that after having copied and attached all this information about the test plan, we need to have access to the change candidate. So here what happens is that we ask the user to provide a URL for the location of the change implementation in terms of code. It's copied directly from GitHub. Based on this information, actually, now the agents have access to the code and can really perform test execution. So this is the test executor agent that is called and executed behind the scenes. I've attached the change candidate. Please execute the tests. And what you can see here now is that the test plan is going to be decomposed in multiple test cases that may leverage different tools, as we have seen before, and have both an outcome, success or failed, and a description of what happened. Let me accelerate a bit. So here is also detailing the different operation, analyzing test plan, forking, production snapshot, applying the change, recomputing. We are giving you a bit more information about what's going on because we think that it's very important for this solution to provide transparency into what they are doing so that all these steps can be double-checked. And so here, the 3 test cases were completed. And actually, what does after that is formatting the final test report. It's a simple PDF explaining what went well, what went wrong, and why. What's important to underline, that is also true in the definition of the test plan, is that here we are not just checking that the intent of the change is satisfied. That is, of course, a requirement. But we are also checking through the definition of counterexamples that there are no unintended consequences.
So you're defining your intent in ServiceNow, and at some point you're generating this test plan based off of what you input into ServiceNow?
Yeah. It's automated. It is actually the agent reason and say it takes the intent, it takes the status of the networks, it takes his memory of, OK, this type of change is required to do these tests. He formats the test plan based on a template that we have provided him, and then it outputs.
And this is all off the information gleaned off of the network, right? But is there any other models that's feeding data to this as well, like any Cisco models or like deep learning models, networking models that are being used?
Here, all the tools are in the entity that we have seen. You could enrich it because, again, what we have done is essentially build this abstraction so that you can integrate multiple tools behind.
Yeah,
we have started with a few, but in principle, you could.
I'm wondering if like there would be like a RAG component where you would feed it data, specific to not just gleaning the information and topology, but networking data so that it can generate these test plans or these configs, right?
this is done by using the NDT and based on the networking data. It's not done using RAG. We have done some experiments. It was less performant than just computing on the graph in the graph DB. But that could be an option. But yeah, this is all related to the networking data. And even there, you can add more connectors. So at the moment, I was showing the stack of the type of data that we have. In principle, you can go up to the application layer. We have in our roadmap to have a Splunk connectors. You can even have application telemetry. I think there was another question. Yes, please go ahead.
As you go from one agent to the next in those different steps, do you provide the next agent every time through context of
Yes.
the steps, or do you summarize? Or?
Context is passed from agent to agent. The data related to the test execution remains stored in the knowledge graph. It's not in the production data because, of course, the network digital map will follow its flow, but it's added as metadata for each test that has been performed. And so this is always accessible to the agents. The agents can always have access to all the structured information, even the history about the past changes. Here, I just wanted to show quickly, so let me move on. The network digital map, this is the way, this is not specific to a change request, so that's why we had a different recording. Essentially, you can see the network digital map, and you can browse to the different layers. So here, for instance, you have layer 1 in the selector, but you can have the other layers, and you have this is a very small network scenario, but you can have all the metadata associated that is stored in the side panel. Don't have a lot of time. I want to really say a few words about how these agents have been built. And I think this is also interesting if you want to get started beyond these agents or trying to use the tools and develop agents that are specialized in your process. So we have launched this agency, which is an open source collective, in March. And we are very actively working, not just the teams working on this project, but our entire organization. What we believe will happen, and is important that we accelerate, is that people developing agents will also be put in condition to use third-party agents or tools and agents developed with different agentic frameworks. So we really believe, because we are Cisco, in the Internet of Agents. That's how we call it. And so these projects, we have started open sourcing components. These are the ones that you see in blue. So for instance, we have defined an open agentic schema framework. And I can probably show you very quickly the one of those agents, which is the equivalent, if you're familiar with it, with the OCSF. OCSF is the Open Cybersecurity Schema Framework. We have started something similar for agentic. When you want to describe an agent, it's important you have a schema that allows you to understand who was the publisher, what are the skills, so that you can discover the skills, what are the capabilities. It has been evaluated, these agents or these skills, because you don't want to trust anyone's agent and put it in your production network. So this is the navigator. You have all the pointers. If you go browse agency.org, you have the link in my slides. But this is how agents appear in this catalog of agents that we call directory, where people can go and browse for the agents and compose them. Sorry, we lost. Let me share again. Other important components are, for instance, the observability and evaluation components. This is additional work. I wanted to show you the Ether agents as they appeared in our observability solution. Just taking a couple of agents. It's very basic UI. But here you can see that for this application, we are able to reconstruct first of all, what is the list of agents, their cost, their latency, their characteristics. But you can also reconstruct the execution graph. And this is something that, especially when the agents are distributed, is not so easy to do. And so what we want is really provide full transparency also for user of the network change validation agentic solution, so that people can get familiar and trust and monitor what's happening when these agents collaborate behind the scenes. So here you see some of the agents we have seen before, and you can even look into the metadata coming from an hotel-based telemetry, because we are trying also there for observability to standardize the format of agentic telemetry using open telemetry. That's been very important, and this is an effort that we're going to continue. I just wanted to summarize, based on this year of work, what are some lessons learned and next steps. As I said, we have come to this project being still very skeptical about agents' capabilities, and we have been, I would say, really blown away by the results of assembling these agents and the reduction in terms of cost, of the speed, the acceleration brought by our solution, the reduction of errors in production due to misconfiguration, etc. And so we really think that this is the way forward. Of course, there is still a lot to do, especially on making the development of these agents more predictable, because these agents are by nature non-deterministic. And so there is a lot of work to do to make them collaborate and use tools in a way that gets provable and predictable performance. But yeah, so far, I would say the balance really is for benefits more than challenges. And what we are doing is, so we plan to extend this use case in many directions. We plan to apply more of the agentic tooling and protocols. We plan to have multiple sub-scenarios that see these agents collaborating. We plan to offer the NDT capabilities so that people can develop their own agents and agentic solution following the same paradigm. So we are very interested, I would say, check what's going on in Agency, which is our open source solution. We are in parallel working still with customer and partners. We have a good collaboration here, for instance, with Swisscom. We have used their network and their past incidents to test and prove the value of this solution. And yeah, I stop here. Any question? Just providing here the pointers to another person in my team is the main architect in terms of engineering, and our product manager, Ola. We, again, will be very happy to have your feedback or suggestion for improvement, to work with you to apply this solution to your networks. And agency.org is the open source initiative that I've been mentioning all throughout. That said, I hope that you enjoyed this session. I'm still here for questions if you want. Please don't forget to submit your session evaluation. That's very important for us to get a feedback. And have safe travel back. Thank you, everyone.